All right, you have a warm-up. Good morning. I'm looking at two quadrilaterals. I want you to start on this side of the warm-up, please. So you're looking at two quadrilaterals, and the conversation is, can we prove that these two figures are congruent? And if so, I want you to write a congruent statement. And then I want you to discuss with your group, how did Euclid's congruent postulates, and remember, these congruent postulates that he gave us were actually for triangles. So up here is a conversation about a quadrilateral, a four-sided figure. Down here we talk about triangles. If you and your group figure this out and pop over to the back, go ahead, but I want you to start here on your market set, go. Okay, the congruent statement is so easy, it's hard. So Olivia's got all of her colors out and she says, hey, I have two 136-degree angles. That's awesome. I have a 103 angle that's next to and next to, but in a different direction. Is that okay?
Yes.
Yeah, as long as we continue with our angles matching up in the same order. Nobody said same direction was necessary, but I have all of these congruent conversations happening. Now I got to look at my sides. I have an 18-foot segment between my red and my purple. 18 between my red and purple. That's good. 16 between red and pink. 16 between red and pink. So these ones are good. 40 between purple and green. Purple and green, 40. Got it. 32 between pink and green. 32 between pink and green. So I definitely know that yes, I can prove these triangles are congruent because all congruent angles are going to prove that these two figures are the same shape, and all congruent sides are going to prove that these two figures are the same size. So can I prove it's congruent? Yes, I can. If I have four sides in my figure, I need four side lengths and four angles. I need 8 pieces of information. If I had a figure that was 5-sided, how many pieces of information would I need? Sides and angles? 10. If I had a 10-sided figure, how many pieces of information would I need? 20, okay? So once I guarantee that all sides and all angles are congruent, I can write my congruent statement. It's a quadrilateral, so I'm just going to draw a 4-sided shape. And when I name this one, it's going to set the stage for how I name this one. I can start with any vertex. Call one out. Go.
H.
H. I heard it. Okay. When I name my figure, I have to go either from H to I or H to K. Nobody cares which way around the figure I go. How do you want to go?
H-I-J-K.
H-I-J-K is guaranteed to be congruent
P-O-N-M.
to figure. H corresponds to M. I corresponds to N. J corresponds to O. And K corresponds to P. I communicate, and remember, two things are very, very important. You have to go ring around the rosy order, and you have to make sure that you name and communicate corresponding vertices for your congruent figures. Got it? All right. Geometry friends got together. They had a meeting, and they decided that was too much work. Proving all congruent sides and all congruent angles. We got better things to do at our time, so they petitioned Euclid. They protested. They said, hey, is there a more efficient way of doing it? What did Euclid come up with? He came up with these postulates, and he says, if you can find three sides of a triangle only that are congruent. You don't have to worry about the angles. Like, okay. All right. Thank you. Anything else? He says, if you can find two sides and the included angle, you don't have to find anything else. If you can find two angles and the included side, you don't have to find anything else. With your group mates, please, would you please tell each other what the included angle and side means? Go. So our included angle is going to be an important conversation. This side is included in B and C. This side is included in angles F and E. This angle is included in these two sides, and this angle is included in those two sides. That's what I mean by included. Go ahead.
Included angle is basically the angle that's the same for both triangles.
Yeah, the angle, no, the included angle is going to be the angle that's included in the sides that I'm mentioning. Remember, you put your fingers up. This is your included angle between your thumb and your forefinger, right in here. Okay?
So if I was talking about E, the included angle would be B.
If I'm talking about, say what?
For the A,
Yeah.
if I were to go to E, my included angle would be B.
So if I'm talking about E, your corresponding angle would be D. If you want to know which sides include E, it would be DE and FE include E.
Okay.
Okay? All right, so when we go to write in a congruent statement for each triangle and state the postulate that supports your statement, each of these can be proven congruent. This one is through side, angle, side. This one's through side, side, side. And this one's through side, angle, side again, right?
How was the first one side, angle, side? Isn't that angle, side, angle?
I knew that wasn't right. How's that?
Because there's two angles in one side.
Absolutely. Go put a smarty up. All right, so the next important part is to go ahead and write a congruent statement. Somebody call out a way to name this triangle here. Once we say that it's triangle A, B, C, we know that then it's congruent to A corresponds with D, B corresponds with E, C corresponds with F. That's how that one has to be named. All right, somebody call out a way to name this triangle here. H, P, O. Once Ethan calls this HPO, what letter do I have to start with? S, then I have to go to what? N, then I have to go to what? Very good. Okay, come on over here. Triangle A, oops, AMN I heard, is congruent to triangle. Once we start with A, we have to start with O. Once I go to M, I have to go to J. And then once I go to N, I have to go to B. All right, so here's an important conversation that I want you guys talking about. Neither of these two sets of triangles below can be proven congruent by side, 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 angle, side, or angle, side, angle. Is everybody okay with that statement?
Yes.
You can't do it with the information given. I have here two angles and a side, but that side's not included. I have here two sides and an angle, but this angle's not included. So I cannot use side, angle, side, I cannot use angle, side, angle, and I cannot use side, side, side. But I'm telling you right now, these triangles can still be proven congruent. Talk to your group mates and see if you can figure out how. You're not gonna say go. I know what it is. All right, come back to me. Let's talk about this set first. Let's talk about this set first. I have two angles on a side, but that side is not the included side. So I cannot use angle, side, angle. What can I do? Who has an idea? Maggie, go ahead. So if you remember our third angle theorem, that's the one that says if you have two angles of a triangle congruent to two angles of another triangle, then you know what? That the third angle is also congruent. So now I have this angle is congruent to this angle, and if you notice, now I have side, side, side congruent, or no, I have angle, side, angle congruence. So our third angle theorem makes that possible. Good job. Let's go on to the next one. I have a right angle. I have this leg, and I have this hypotenuse. What do I know about right triangles? Should we phone a friend? What friend could we call about right triangles? He loves them. Let's call Pythagoras. Hey, Pythagoras, it's Mrs. Glazier's 5th period amazing geometry class. We've got a right triangle. What could we do with it? Who has an answer? Solve for what? Okay. Olivia wants to solve the side. Do you see it yet? If I call this A, and I call this B, and I call this C, what do we know about right triangles?
That a to the power of 2 plus b to the power of 2 is equal to c to the power of 2.
So for this one, b squared is going to be equal to c squared minus a squared. You okay with that? Because aren't I solving for b? So isn't it going to be the same because a and c are the same? So if I put this guy through Pythagoras, am I going to be able to prove that that's congruent to itself?
Yes.
So what kind of congruence do I have?
Side, side, side.
How cool is that?
Wow.
How cool is that, right? Hey, that's what we're getting to today. Take out your homework first. Marcus said take it out. All right, let's talk about the homework. If you had to explain to a friend how to answer 1, 2, 3, and 4, what would you tell them? The included angle is?
The letter is on both.
Yeah. There's my T's, and here's my C's, and here's my G's, and here's my S's. It's the vertex that's shared by the two sides of the triangle. Okay? All right, so check out my postulates. Adnay and I were talking about A, and he says, I know the lines are parallel, and I know there's some pretty cool relationships, but is it enough to prove the triangles are congruent? Not for this one, but yes for this one. So with those parallel lines, you can get alternating interior angles. Look at the difference between A and D. This here is not enough for me to get congruence because that angle gives me angle side side, and that's not one of our postulates. So the AS postulate does not exist because there's no cursing in geometry. Like a donkey. Right? So here that parallel side was given to me as congruent, so I can use this alternating interior angle in letter D to get my side, angle side. Do you see the difference between A and D? Go ahead, Rachel.
So for B, wouldn't it be angle side angle? Because
So I
where
don't.
do you get the other side from?
So do you see this side here?
Uh-huh.
Do you see this right angle here?
Yeah.
Do you see the shared side? There it is, side, angle, side.
Oh, wait.
Right? That overlap side. That's good. That's good. Keep looking at it. Hey, don't forget that all right angles are congruent. So all the stuff that we've learned in the past, it's like somebody just stirred the pot of soup. You're like, wait, we gotta remember about right angles? Yes, you do. You're like, wait, we have these overlapping sides, reflexive property? Yes, you do. Just stir it up and all that stuff comes back up to the top. What do you call these?
Vertical angles.
Vertical angles are congruent, side angle, side. Here's another shared side for side, side, side. In this one, we have a shared side, but angle, side, side is not a postulate we have. No cursing in geometry. All right, next coming up, completing this statement, making sure that we understand corresponding parts. And then I'm telling you what, by the end of Unit 4, you will be proof masters. By the end of Unit 4, we are doing a proof every single day. So if you are a person who's been saying no thank you to proofs, it's time for you to say yes, please. It's also time for you to start talking to your diagrams. It's time for you to start putting that information, given O is the midpoint of those two segments, you're going to go right away and draw what those congruent representations mean. That's our given information. O is the midpoint of those two segments. Our definition of midpoint then says that it's going to evenly divide those segments. I love how we get vertical angles. And then we can use our side, angle, side congruence postulate to prove that. Questions on this one? So if you're a proof pantry person and you want to make a list, you should be paying attention to the things that we see happening over and over again. Midpoints, vertical angles, alternate interior angles, reflexive property, all those ideas. Back.
Why is the third one vertical angles? I put definition of congruence.
Because these two angles are congruent because they're vertical angles. So that's the justification, okay? All right, next step on the back. I really wanted to write more in my paragraph proof, but there was like nothing more for me to say. Write a paragraph proof. We are given segment AB is congruent to segment CD and BC is congruent to DA. Here's our next justification. We want to make sure we remember these two are congruent by the reflexive property of congruence. Notice these have to be written as CA and AC because in each triangle they're corresponding backwards because the triangles are flipped around. Do you see it? It's tricky. So then I have side, side, side congruence. All right, write a two-column proof. Here we go. Write your given. Everybody who left those proofs blank, whenever you're curious, start off with your given. Write down what you know. And talk to your diagram. This diagram came to you blank. You fill in the information. These two lines are both parallel and congruent. If you need to, spin your paper sideways so that you can see your alternating interior angles. Go ahead, do so, whatever works for you. And then I have that reflexive property shares my side. And then I have side angle, side congruence. These ones were tricky because once I recognized that this congruent statement was given to me, I know that A and D are congruent to each other, so I can set them equal to each other and solve. Once I solve for X, I can plug it back in and solve for all my other angles. It's not a problem.
How'd you do that?
I set these congruent angles equal to each other.
Yes.
Got a value of 10 for X. So angles B and E are worth X because they are corresponding angles. A and D are worth 20 because I put 10 in for X. And then I added them up, subtracted from 180.
Oh, okay.
Okay.
But why did you only do 10x?
Why did I who?
Why did you only use 10x and 2x?
That's all I needed. Once I knew what X was, it gave me all my values.
Oh, okay.
My sides were a different X. I knew that BC and EF were corresponding sides, so I set them equal to each other, and for the sides, my X has a value of 2. So when I plugged it in, I got the distance from B to C is 8, and the distance from A to C is 19. All right, for 14, find the value of the variables. So I went through and found out which one matches up with which one. And I was good to go. How we doing?
I was a little bit confused on the last one.
So, what can I answer for you?
So you would have to do 2x minus 5
Yes.
is equal to 4x minus 15.
Yes, ma'am.
But how did you find the angles?
So, you gotta focus on whether your information is sides or angles. Here I have x is equal to 5, so that tells me this side is 5 and this side is 14 because that's from here, right? I said these two y values equal to each other over here. Y has a value of 5. That's how I get 18 for each of these sides. When I'm doing angles, I'm going to go corresponding. U is 57 because that's given. For this one, I knew that 57 plus W plus 7 is 180. So I dealt with this triangle first, and I got a value of 58 for W.
Oh, I get it now. Thank you.
Yeah. All right. Take a look at your homework and turn to your partners and say what you think would make a good quiz question. Go. Okay, so I loved the two different perspectives that I heard. I heard Abdullah say this would be the best problem to include on the quiz. Because why? Say it. Woof, woof. That's the first proof he's gotten right all year. Go put a smarty up. Good job, Abdullah. And then the other perspective was I heard Olivia say these questions would get me. They'd be good quiz questions. So Abdullah is setting himself up for success, and Olivia's like, I would put the hardest one on the quiz. Right? What other thoughts do we have about the homework and what would make a good quiz question? 1 through 4. Because you thought they were the easiest? Okay. I'll buy that. Any other comments? Why am I asking about quiz questions? Because you have a quiz next class. Hey, what we're doing and testing you on the quizzes is no secrets. So everything that's on the notes, the practice homework, all fair game. So you should be approaching each of these. If you're a person who wants to do better on the quizzes, which I think describes most of you, then you should be approaching every single thing we do in class with that in your mind. Is she putting this on the quiz? How would I do if this was on the quiz? What would this look like as a quiz question? Because the kids that are critically thinking about that and spinning it around in their heads are the ones that are doing better. Trust me. All right, guess what? The work that you did here on third angle theorem and working this around to angle side angle, Euclid heard you loud and clear. And he said, I'm not making it a postulate because you can prove it, but I will let you have your shortcut. Because if you can prove that two angles and one side of a triangle are congruent to two angles and one side of another triangle, nobody cares if that side is the included one. People aren't worried about that because if you are missing your third angle, we know that your third angle theorem will give it to you, and you can always then use angle side angle. So we're going to save you a step, and we're going to tell you if you have two angles, any two angles, and a side, any side, whether it's included or not, you can use that as a justification for proving triangle congruence without having to go ahead and prove that third angle. Now here's the tricky part. You're going to have to tell the difference between angle, angle, side, and angle, side, angle. And that comes from understanding what I mean by an included angle. Got it? So when we use angle, angle, side to prove triangles are congruent, all we need is two angles, any two angles, and one side. With your group, complete this proof. And your mark is set, go. All right, you ready? Our given statement is that segment WY is parallel to segment XZ, and this is already marked on my diagram. I'm a huge diagram talker. I think it's important that every time somebody gives you information, you make sure that you represent it on your diagram. Sometimes the diagrams have the markings on them. Sometimes they don't. All right, that's been our given. Now we have our alternate interior angles theorem. So I got to go find me some alternate interior angles. Again, if it's easier for you to extend your sides, please do so. If it's easier for you to spin your paper so that you can see your transversal, please do so. Because here is where I have alternating interior angles. Do you see them now?
Yes.
So then when I go to name them, I know that angle ZWY is going to be congruent, ZWY, to angle WZX. Two questions for you. How come I couldn't just call them angle W and angle Z? How come I couldn't call it angle W?
It could be for any triangle.
Great. So which angle? Right? Angle W. If it's not clear which angle W, can't use it. Okay, notice I was real careful about the order that I named my angles. Because when I named this one ZWY and I named this one WZX, I put the letters in corresponding order. Super important. All right, reflexive property of congruence tells me that this segment is congruent to itself. But please be very careful because WZ is congruent to ZW. It's not always going to be flipped, but when the triangles are connected like this, if I talk about going from my pink angle down, that's WZ. For this triangle, that's going to be ZW. So make sure you understand why those have to be listed the way they are. Do you see now how I have two angles and a side are congruent to two angles and a side? Question for you. Do you want to add more lines onto this proof and use the third angle theorem and angle side angle? Or do you just want to go with it as is? That's what I thought. Shortcuts. Because I have two angles and a side, I know that triangle WYZ is congruent to triangle X or ZXW.
Can't you just say angle side angle?
I cannot say angle side angle unless I go and take the time to use my third angle theorem. Because this proof, Olivia, and this diagram does not support angle side angle. I don't have this angle
Oh,
that makes this my included side. I don't have that. So guess what? I cannot use angle side angle. If you put angle side angle, you're gonna get it wrong. If you put things in the wrong order, you're gonna lose points. So it's easy proof, but lots of details we gotta pay attention to. All right, next big question. Why do we have no angle, angle, angle? Talk to your group. Read through this and tell me why. Why not? Adne, go ahead.
You could have the same angles, but the lengths could be different.
Yeah. Perfect. You need at least one side, one pair of corresponding sides. Hey, challenge yourself to draw a triangle that looks like this, but is teensy. So give yourself P and R and Q. And tell yourself that this has the same measure as Z, and this has the same measure of Y, and this has the same measure of X. But no one would ever call those triangles congruent.
No.
When we get to Unit 6, which is what's next, we're going to call them similar. Similar triangles have the same shape. All my angles are the same. But similar triangles do not necessarily have to have the same size. So these are not congruent because I need at least one side in order to establish how big it is. Anybody ever see those jokes about people that order stuff off the internet and they think it's going to come big and it comes as...
yeah.
You need a measure, right? Without a measure, who knows what you're getting show up in the mail. All right, ready? Next one. So you are not allowed to curse in geometry. There is no ass theorem. There is no ass theorem. And the reason why there is no ass theorem, I'll show you in a minute. I just have to pull up the website. I want you to look carefully at these triangles. And I want you to see this first set of triangles. I have angle A is congruent to angle A. AB is congruent to this AB, and this BC is congruent. So one might say that those triangles are congruent. But the interesting thing is they are not congruent because that orientation of shapes does not guarantee that our side stays where we put it. If you look here, it swings. Trying to get it to swing. There it goes. So if I have angle A and side B, no measurement of that triangle is guaranteeing that BC is either in the left position or the right position because nobody gave me this angle measure or that angle measure. So because I have neither of these two angle measures or the length of this side, ABC is one triangle, ABD is a second triangle, and they each have those matching two sides and one angle. So without having this angle in the middle for side angle side, or this angle here for angle side angle, or the length of this side for side angle side, without having those measurements, I can't guarantee whether I'm looking at triangle ABC or ABD. What's on your mind? So if somebody told me that it was isosceles, then I'd have the two angles across from them. So I would have more information from knowing what an isosceles triangle is, right? But if I'm only given one angle and two sides, it's not enough to differentiate which triangle are you talking about. This obtuse triangle, ABC, or the acute triangle, ABD. So because those two possibilities exist, I need to know which triangle are you talking about. This one here where it's acute or where it's obtuse, or this one here where this distance is much longer and this angle is acute. Okay, so without knowing the measure of angle B up here, how big is it? Skinny or bigger? What is the measure of angle C, obtuse or acute? What is the length of AC, short or long? Both triangles are possible with that information. Therefore, there's no theorem that has two sides and the angle that's unrelated. All right. Until we talk about the one we already proved. And you're like, wait, didn't we do it here? For this one, didn't we have one angle and two sides? And I'm like, yes, but that was a right angle. So because that was a right angle, there's no shot at having to worry about this obtuse or acute story. And I was able to use Pythagoras to solve for my third side. So guess what? We have one more theorem that we've already proven. We've already said that if I have a right triangle, I can go ahead and do that. This version is okay because my right angle guarantees that there's no obtuse angle, and I can use Pythagoras, the Pythagorean theorem, to find my third side for side, side, side. If you know the hypotenuse and one of the legs of a right triangle, here's my hypotenuse, and here's one of my legs. It doesn't matter which one. If you know that the hypotenuse of one of the legs is congruent to the hypotenuse and the leg of the other triangle, then you can go ahead and say that they are congruent. One last quick thought. There are 4 sets of triangles here. 1, 2, 3, 4. Can you tell the difference between angle side side and hypotenuse leg? Think about it over lunch. All right, welcome back. I like this part. I like this part of the worksheet because we really have to think about what we're thinking about while we're thinking about it. That's that whole metacognition, paying attention to what's going on in our brains. And what I want you to think about is, can you tell the difference between whether something is hypotenuse leg, which is okay, and whether we're looking at angle side side, which is not. So with your partners, please take a look at these 4 sets of triangles. And I'd like you to identify which ones are hypotenuse leg. We're like, yeah, we could prove these are congruent. I'm good with that. Or no, these ones break the rules. As a challenge, if you determine something is angle side side, see if you can draw the 2 triangles. So check out the pictures on the top and see if you can see which side might have the swing. See if you can draw the 2 different possible triangles that might result because that angle measure or side length was not guaranteed. On your mark, get set, talk, think, go. All right, so let's talk about this one. Would you call it angle side side or hypotenuse leg?
Hypotenuse leg.
That's the kicker. As soon as you see a right angle, then you know that you can get that 3rd side congruent through the Pythagorean theorem, so that having 1 angle and 2 sides is perfect. So hypotenuse leg, not a problem. All right, let's talk about these 2. These are our sides where I have 1 angle, and 2 sides where that angle is not the included angle. So the challenge here is, can you draw the other side and see if you can find the other triangle? Anybody have any luck? Anybody have any luck? So with this one, I want you to imagine BC here. I want you to imagine BC swinging in. Do you see the isosceles triangle? There's nothing that says that BC cannot be in here, right? So with this side and this angle, this second triangle is possible, therefore you can't guarantee that these are congruent. So we're going to say that that's angle side side, which is not one of our postulates because no cursing in geometry. So therefore, what we're going to say is we're going to say not enough information. I need another angle. I need another side in order to guarantee that those are congruent. All right, so take a look at the other triangles. If I have this angle and these 2 sides, I don't see, I'm struggling to see this one, and I wonder if it's because C and E appears to be an obtuse angle, right? So I'm struggling to see my second triangle. Anybody see it? Anybody else have it? All right, so let's just make sure that we're on the same page with these. You have 3 congruence postulates that Euclid gave you. 3 rules that we did not have to prove. He said 3 sides of a triangle congruent to 3 sides of another triangle, you're good to go. He said if you have an angle included between 2 congruent sides, you're good to go. He said if you have a side included between 2 angles that are congruent, you're good to go. That was last class's notes. This class, we came up with 2 theorems that were like, hey, but what about? if I have two angles and the side that's not included, and you could scratch this head and say, you know what, you could use the third angle theorem to get yourself back to angle side angle, so let's go ahead and just call that a theorem, right? And then what if we said that this was a right angle and I had two sides and a right angle? I know I'm not allowed to do angle side side, but if that angle's a right angle, I could use Pythagorean theorem to find the third side, and then I got side side congruence. So can we call this one hypotenuse leg for my right triangle? And he said yes. These two, he will never say yes to. Because this does not guarantee same size, and this does not guarantee one exact triangle if I can make two potentially. So these are the no-nos. So make sure you have those answers down. All right, so what I'm going to do